size limitation on flexible conduit is influenced by several factors. Firstly, mechanical strength is a primary concern. Larger flexible conduits may lack the necessary mechanical strength to support the weight of cables, especially when suspended. This can lead to sagging, damage to the conduit, or even failure of the installation. Secondly, handling and installation difficulty plays a significant role. Handling and installing large flexible conduits can be cumbersome and pose safety hazards. The increased weight and size make it harder to maneuver and secure the conduit properly. Thirdly, the increased risk of damage is a consideration. Larger conduits have a greater surface area, which increases the risk of damage from impact, vibration, or other external forces. This can compromise the integrity of the wiring system. Circuit capacity can also be a factor. Larger conduits may lead to higher circuit capacity, which can be a violation of code requirements, as the intended design and capacity of the circuit may be exceeded. Conduit fill is another important aspect. Larger conduits may exceed the maximum allowable fill percentage, affecting wire dirting and increasing the risk of overheating. Overfilling can also make it difficult to pull cables through the conduit. While the code generally limits flexible conduit to 4 inches, certain exceptions may apply. For example, Chapter 6.0 of the National Electrical Code, NEC, special equipment allows for larger flexible conduits for specific applications such as dust-tight enclosures, hazardous classified locations, and motor feeders. Additionally, local authorities or AHJ authorities having jurisdiction may have specific requirements or exceptions regarding flexible conduit sizes. There are also specific concerns about 5-inch and 6-inch flexible conduits. Sidewall pressure is a major issue. The sidewall pressure on large flexible conduits increases significantly as the size increases. This can damage cables or the conduit itself, especially during installation or when the conduit is bent. Cable damage is another concern. Large flexible conduits may not provide adequate protection for cables during pulling, especially if the cables are heavy or have sharp edges. The flexibility of the conduit can exacerbate this issue. Sealing is also a factor. While some flexible conduits may provide good sealing against liquid intrusion, it is not guaranteed. Welded or threaded fittings are not required for all flexible conduits, and they may not be effective in all applications. It is important to note that the code does not apply to power plants, but the owner is asking why the size limitation exists. When working with flexible conduits, it is important to follow the code requirements in the specific jurisdiction where the project is located. It is also advisable to consult with the manufacturer of the flexible conduit to ensure its suitability for the intended application. Consider potential issues with mechanical strength, handling, installation, and cable protection when using large flexible conduits. If necessary, obtain an exception from the relevant authority or AHA to use larger flexible conduits. Furthermore, ensure proper support is installed when the conduits are properly placed in the installation. Ensure you follow the NEC tables when installing and supporting the conduit. These tables will help assist with the correct distance apart. Support must be installed within 12 inches from any box, fitting, or termination. The NEC has established rules for conduit and cable support that must be followed. The requirements differ depending on the type of wiring method, the trade size of the conduit or cable, and the application. The NEC specifies requirements for supporting different wiring methods, including conduit and cable. The purpose of these requirements is to ensure that the wiring system is installed in a neat and workmanlike manner and that it is adequately supported to prevent damage or strain on the conductors. For example, NEC Section 314.23 addresses the support of boxes and conduit bodies. This section provides requirements for supporting boxes and conduit bodies used in electrical installations. The general rule is that boxes and conduit bodies must be securely supported to the building structure or to other approved means. The specific requirements for support vary depending on the size and weight of the box or conduit body, the type of wiring method used, and the application. The NEC also provides requirements for supporting different types of conduit, such as rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. The requirements vary depending on the type and size of the conduit, the spacing between supports, and the application. For example, NEC Section 344.30 provides requirements for supporting rigid metal conduit. This section requires that rigid metal conduit be supported at intervals not exceeding 10 feet. The NEC also provides requirements for supporting cables such as non-metallic sheathed cable, armored cable, and metal-clad cable. The requirements vary depending on the type and size of the cable, the spacing between supports, and the application. For example, NEC Section 334.30 provides requirements for supporting non-metallic sheathed cable. This section requires that non-metallic sheathed cable be supported at intervals not exceeding 1/2 feet. In addition to the general requirements for supporting wiring methods, the NEC also provides specific requirements for supporting wiring methods in different applications such as in suspended ceilings, in wet locations, and in hazardous locations. It is important to consult the NEC for the specific requirements that apply to the wiring method and application being used. The NEC requirements for conduit and cable support are intended to ensure that the wiring system is installed in a safe and reliable manner. By following these requirements, electrical contractors can help to prevent damage to the wiring system, reduce the risk of electrical shock, and ensure that the wiring system will provide years of reliable service. When dealing with conduit sizes exceeding the typical limitations, especially in situations where older codes are referenced, it's essential to consider the practical implications and potential risks associated with larger diameter flexible conduits. The concerns extend beyond just the integrity and strength of the flexible conduit itself. They encompass the overall system performance and safety. Sidewall pressure, as previously mentioned, becomes a significant issue with larger conduits. The force exerted on the cable insulation as it's pulled around bends can lead to damage, reducing the cable's lifespan and potentially creating electrical hazards. The risk is amplified when dealing with heavier cables or installations with numerous bends. Cable fill, referring to the percentage of the conduit's cross-sectional area occupied by cables, is another critical factor. Exceeding the maximum allowable fill percentage can hinder heat dissipation, leading to conductor overheating and insulation breakdown. Furthermore, overcrowding makes it more challenging to pull cables, increasing the likelihood of damage during installation. Mechanical protection is paramount. While certain flexible conduits offer excellent sealing against liquid intrusion, they might not provide adequate mechanical protection in harsh environments. The flexibility that makes them useful for certain applications can also make them more vulnerable to physical damage from impacts, abrasion, or compression. In power plants, where equipment and infrastructure are often subjected to extreme conditions, this is a significant concern. Regarding cable pulling, large flexible conduits may exhibit greater flexibility, which can complicate the pulling process. Maintaining consistent tension and preventing snags becomes more challenging, increasing the risk of cable damage. The internal surface of the conduit also plays a role. Rough or abrasive surfaces can exacerbate friction and increase the likelihood of insulation damage. The support system for the conduit is also paramount. The older codes referenced in the project may not have adequately addressed the specific challenges associated with supporting larger diameter flexible conduits. Insufficient or improperly spaced supports can lead to sagging, stress concentrations, and even conduit failure. The support system must be designed to handle the weight of the conduit and cables, as well as any external forces. When evaluating the suitability of 5-inch and 6-inch flexible conduits in the context of the 1987 code, it's crucial to consider these factors in conjunction with the specific requirements of that code. While the code may not explicitly prohibit the use of larger conduits, it likely contains provisions related to conductor ampacity, cable fill, mechanical protection, and support that must be adhered to. It's also essential to consider the intended purpose of the flexible conduit. Is it being used to accommodate movement, vibration, or misalignment? Or is it simply a convenient way to route cables? The choice of conduit material and size should be based on a thorough assessment of the application requirements. In situations where the owner is questioning the use of 5-inch flexibles due to concerns about compliance with newer codes, it's important to provide a comprehensive justification for their continued use. This justification should address the specific concerns raised by the owner, demonstrating that the installation meets the intent of the 1987 code and provides an equivalent level of safety and reliability. It's also advisable to consult with qualified electrical engineers and inspectors to ensure that the installation is in accordance with industry best practices. They can provide valuable insights and recommendations based on their expertise and experience. In some cases, it may be necessary to conduct load calculations, cable pulling simulations, or other engineering analyses to demonstrate the suitability of the installation. Documentation is key. Maintain thorough records of all design decisions, calculations, and inspections. This documentation can be invaluable in defending the installation against future challenges or audits. Remember that the primary goal is to ensure the safety and reliability of the electrical system. While it may be tempting to deviate from code requirements to save time or money, it's essential to prioritize safety above all else. A properly installed or undersized flexible conduits can have serious consequences, including electrical shock, fires, and equipment damage.